Building a custom programming language used to require writing proprietary plugins for different editors, creating a massive development burden instead of a unified central beam. Our objective is to bypass this repetition by wrapping your Rust or Go compiler into an isolated service. We are building a write once, run anywhere architecture. To get started, you only need your base compiler logic and a simple implementation of JSON RPC to handle the communication. Moving away from editor-specific plugins is a strategic choice. It ensures your language tooling remains functional even as the editor market shifts toward new platforms. The shift starts with process isolation. Instead of running the compiler as a one-off script, you launch your logic as a continuous, isolated background daemon. This prevents heavy analysis from freezing the editor's interface. The IDE stays responsive, processing in dedicated memory. We bridge the gap between these two processes with the Language Server Protocol, or LSP. This provides the common vocabulary they use to share data. The protocol uses a JSON RPC interface, transmitting payloads over standard input and output channels to maintain a persistent connection between the tools. For example, when you rest your cursor on a variable, the IDE sends a request for hover documentation to the server's standard input. The daemon analyzes the source code, finds the variable definition, and returns a JSON response that populates the tooltip you see on screen. This architecture turns your compiler into a universal microservice. You have successfully decoupled the visual interface from the underlying logic. Effective development requires more than just syntax highlighting. You also need a way to track variables and step through code execution. The DAP adapter protocol, or DAP, serves as the standard for this layer. It allows your language to communicate with an editor's debugger to set breakpoints and inspect memory. To support AI-assisted coding, we integrate a third standard, the Model Context Protocol, or MCP. MCP acts as a secure gateway for AI agents, providing tools like OpenCode with controlled access to your local file system and schemas. This allows the AI to understand your custom language's structural nuances, generating code that respects your specific project context. Stacking LSP for analysis, DAP for debugging, and MCP for AI context provides your language with a complete, interactive environment across any compliant platform. Now that the architecture is defined, we can implement the IDE plugin that launches your standalone binary. IntelliJ recently made this easier by opening the LSP API to all developers for free. This change removes the previous requirement for a paid license to test these integrations. First, open your plugin.xml file and add a dependency on the com.intellij modules.lsp module to enable the protocol features. Next, you create a Kotlin class that extends project-wide LSP server descriptor. This class serves as the configuration for your specific server. Inside that class, the create command line function invokes your Rust or Go binary. Note the --stadio flag, which tells your binary to expect JSON RPC messages. Finally, use the LSP server support provider to ensure the background process only starts when the user opens a file with your specific language extension. When the user opens a relevant file, the IDE instantly initiates the background daemon and establishes the communication link. Implementing these classes establishes a clear division of labor. The IDE manages the window and UI components, while your external binary provides semantic understanding. You now have a high-performance language server actively communicating with a major IDE. By using these standardized protocols, you enable instant code completion, perform real-time live debugging, and add AI-driven context, all from a single service. The strength of this approach is its portability. The same binary can connect to VS Code or Eclipse Thea with minimal changes to the wrapper code. To help you get started, the video description includes the specific IntelliJ plugin templates we used in this project. Using standardized communication protocols allows you to build a resilient language ecosystem that is ready for whichever development platform becomes the next industry standard.